Good afternoon, everyone. Welcome to the class on probability. And in today's class, we'll continue discussion on probability. If you remember yesterday when I was talking about probability, I have defined that whenever we calculate probability, we'll get the value between 0 to 1. Okay, that is what we have learned in probability. That whenever we work on probability, it gives us a value between 0 to 1, where probability is nothing but whenever we say probability, the formula of probability is basically favorable outcome divided by the total outcome. That is a formula of probability. So the formula of probability is favorable outcome divided by the total outcome. That is a formula of probability which gives us the value between 0 to 1. So whenever we work on probability, it gives us a value between 0 to 1. Okay, everyone. So that is what we have learned in the concept of probability till now, that it gives us a value between 0 to 1. Okay, so whenever we discuss about probability, okay, so probability, the concept of probability is basically based on a random experiment. So the concept of probability is basically based on a random experiment. So when we talk about a random experiment, so in the case of random experiment, what do you mean by a random experiment? Before that, let understand what is experiment. So what is basically experiment? Experiment is an action. Okay, what is experiment? Experiment is an action which we follow to get some outcome. So to get an outcome, we perform an action that we call an experiment. So to like if you are aware about Euclid geometry, I hope if you are aware about Euclid geometry, the Euclid did remarkable work on geometry. So Euclid talk about terms like axioms, postulates, corollary, theorem. I hope you are aware about these terms. So statement, what is statement? Statements are those sentences which can give some logical interpretation, which we can get some logical interpretation, either true or false. Axioms are self-evident true statement, okay, which we can apply in any application of mathematics. Postulates are those self-evident true statement which we can only apply in geometry. Those we call as postulates. Okay. Theorems are those statements which we try to prove by taking the help of axioms. So whenever we work on theorem to prove a theorem, certain time if that proof can be done in laboratory, or that proof can be done mathematically, depending upon what kind of theorem is all about, to do that. So many times we do that theorem or that proof or that in laboratory, like especially something related to chemistry and physics. Okay, so if I have to prove that oxygen exists, so I do Lavoisier experiment. I hope you remember, by heating mercury oxide. So you take a test tube and put mercury oxide in that, you heat it and put an inverted funnel on the top of that to prove that carbon dioxide is there. So for that, we'll do that lime water turn milky, all that. So that is the experiment. So experiments are basically the actions what we perform. Okay, so whenever we talk about that kind of experiment, some kind of experiments are random experiments. So where random experiments are those experiments where we know the outcomes. The outcomes are possibly the set of possible result what we can get from an experiment. So that is an outcome. So where we know the outcome, only thing we just try to work on the possibility of getting that outcome. That we call as sample space. So like those are called sample space. The sample space is a set of possible outcome. So if you throw a dice, you'll get a number either 1 or 2 or 3 or 4 or 5 or 6. So this is your sample space. Okay, so I hope you know this. If I ask you the question, a sample space consists of n element. If a sample space consists of n element, if I ask you sample space consists of n elements, So number of subsets possible. So the number of subsets possible. So the number of subsets possible, that will be 2 to the power n. Okay, so the number of proper subset possible. Already you've done all this thing in your PNC. The number of proper subset possible. If I ask you total number of subset proper subset possible, that would be 2 to the power n minus 1. How you get this? This is NC0 plus NC1 plus NC2 plus NC3 till NCN. This is NC0. This sum total of, this is what? This is sum total of, I is equal to from 0. This is sum total of this minus NC0. So proper subset means will not include null set in that. So I hope you understand all this. You have done already all this in your first semester. So when you studied the set theory, PMC and all. So just a recap of that. So you understood what is random experiment. You understood what is sample space. Okay, so you know these terms. So whenever we work on probability, so we discuss the actions. What is probability? Probability is all about working on random experiments. So when we work on random experiment, we perform actions. Those actions are called events. So those events can be simple events, those can be complicated event, compound events. So where two or one more than one events is being done together. Okay, that is called compound event. When you perform only one set of event, it is called a simple event or single event, all that. Where the outcomes, what you get, when you perform these events, these actions, those are called sample space. Okay, so like that you can understand this. Like for an example, if I throw it in the throw of two dice, find the probability of getting one prime and one composite number. So if I throw two dice, what is the probability of getting one prime and one composite number? So I hope first of all you should know the meaning of prime number. What are prime number? What are composite number? I believe you all know prime number, composite number. Prime numbers are those numbers which have only two factors. They are divisible by one and they're divisible by themselves. So when we talk of prime number, we have 25 prime numbers from 1 to 100, and we have 21 prime numbers from 100 to, okay, you should know the prime numbers. The only prime number which is even is 2. 2 is the only prime number which is even. So this is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, then 53, then 59, okay, then 61, then 67, then 69, then 71, okay, then 73, then 79, then 83, then 97. So if you write the prime number, you have total 25 prime numbers from 1 to 100. You have total 21 prime numbers, 25 prime numbers from 1 to 100, where from 1 to 50, you have 15 prime numbers, and from 51 to 100, you have 10 prime numbers. So you can remember this. So after 37, you have 41, then 43, then 57, then 53, then 59, then 61, then 67, then 71, then 73, then 79, then 83, then then 89. 89, is that a prime number? 89, then 97. So you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you can remember this. So when we talk of prime numbers are those numbers which are divisible by one or by themselves. Those are called a prime numbers. So if I throw two dice, if I throw two dice, or if I throw n dice, remember, if I throw n dice, so the total outcome, if I throw n dice, the total outcome will be 6 to the power n. If I throw n dice, the total outcome will be 6 to the power n. While remember that if I throw n coin, the total outcome will be 2 to the power n. You can understand this. Okay, so remember this part. Okay, so remember this part. You can also remember direct formula, the probability of getting n head, probability of getting n head or n tail, probability of getting r head or r tail when n coins are tossed together. When n coins are tossed together, you can remember the direct shortcut formula, probability of getting r heads or r tail when n coins are tossed together. When n coins are tossed together, the probability of getting r head or r tail when n coins are tossed together. So you can remember the probability as NCR by 2 to the power n. This is the direct answer. You remember, never forget this form. So it will always be helpful for you. Any question if it comes on coin, so remember that. So you directly apply this formula. Your work will be done. The probability of getting R hit or R hit when n coins are tossed together, that will be NCR by 2 to the power n. Clear, everyone? So remember this, guys. So when if I talk about two coins, if the two coins are there, so if two dice are tossed together, if I say two dice are tossed together, then total outcome, sum total of outcome, total outcome will be 6 to the power 2, means 36. If I ask you three dice are tossed together, if I ask you three dice are tossed together, if I ask you three dice are tossed together, if I ask you three dice are tossed together, then the total sum of outcome will be 6 to the power 3, means 216. Similarly, if I ask you that four dice are tossed together, similarly, if I ask you that four dice are together, similarly, if I ask you four dice are tossed together, then the total outcome will be 1296. I hope you are understanding this part. So if two dice are tossed together, and what is the probability of getting one prime and one composite number? So you can understand this. In the case of dice, the total outcome is like, you know that if two dice are there, then you will have 1, 1, 1, 2, 1, 3, 1, 4. Like this, you will have total 36 outcome, like 1, 6, then 2, 1, 2, 2, like this. Then you have 3, 1, 3, 2, 6. Then you have 4, 1, 4, 1, 4, 2, like this. 6 outcome. Then you have 5, 1, 5, 2, 5, 6. Then you can have 6, 1, 6, 2, like this. 6, 6. Total you will have 36 outcomes. What I want those outcomes in the sense that one should be prime, another one should be composite. Like that I want, no? I want one outcome to be prime, another outcome to be composite. So if you understand, guys, in 1, 2, 3, 4, 5, 6, how many are prime number? Prime number are 2, 3, 5. Okay, how many are composite number? Your composite number are 4 and 6. One is neither prime, neither composite. When you see one is neither prime, neither composite. So if I talk about favorable outcome, if I talk about my favorable outcome, that would be 2 comma 4 or 4 comma 2. That can be 2 comma 6 or 6 comma 2. It can be it can be 3 comma 4 or 3 comma 6, or it can be 4 comma 3 or 6 comma 3. It can be 3 comma 6 or 6 comma 3. 1 minute. So it can be 3 comma 4 or 4 comma 3. It can be 3 comma 6 or 6 comma 3. It can be 5 comma 4 or 4 comma 5. It can be 5 comma 6 or 6 comma 5. So your favorable outcome are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your favorable outcome, your number of favorable outcome is 12 and total outcome was 36. So your probability will be favorable outcome divided by total outcome. So your probability would be favorable outcome divided by total outcome is 12 by 36 means 1 by 3. Clear everyone? Anyone, any doubt? Anyone, any doubt with this? Fine, I hope you understood. Any other dice based question? 1 minute, let me search. Any other dice based question? You see this question number 10. You want to try this question, guys? Answer you know. You want to try this question? You want to try this question? Answer is 1 by 3. How will you get 1 by 3? Try this. Now, if you see this question, question number 10, two fair dice are thrown, given that the sum on the dice is less than or equal to 4. The sum is either 4 or less than 4. So the minimum sum what you get on dice is 2, 1, comma 1. It can be 3, 1, comma 2 or 2, comma 1. It can be 3, it can be 3. So it can be 3. It can be 3, it can be 3, 1, comma 2 or 2, comma 1. Or the sum can be 4. 4 means 1, comma 3 or 2, comma 2. Can you understand? So the sum, if you talk about sum on two dice, the sum on two dice, if you see, uh, the sum on two dice can be 2, it can be 3, it can be 3, it can be 3, or the sum can be 4, or the your sum can be 4, or your sum can be 4. So 2, 3, and then 4. So 2, 3, and then 4. So total outcomes you are getting is 6. Here you can see it's given already that the sum is either 4 or less than 4. So in that case, if you see the value, the total outcome is 6. Okay, so given that the sum on the dice is less than or equal to 4, find the probability that only one dice should 2. Find the probability that only one dice should 2. So what would be the favorable outcome then? Only one dice should 2. One dice should 2 means your favorable outcome will be 1, comma 2 or 2, comma 1. So your favorable outcome, only one dice should 2. Not the two dice, both the dice, only one dice should 2. Only one die should do. So your favorable outcome will be either 1, comma 2 or 2, comma 1. So your probability, so the favorable outcome is 2. So your probability will be 2 by 6 or 1 by 3. Anyone, any doubt? So your probability will be 1 by 3. Anyone, any doubt? See this, if anyone have any doubt, please ask me. Clear? Anyone have any doubt? Okay, if I ask you this question, one question, that three dice are tossed together, are tossed together, three dice are tossed together. What is the probability? What is the probability? What is the probability to get? What is the probability to get at least one head? Can you do this question, guys? Not one head, at least one head. I'm saying at least 1/6. At least 1/6. Three dice are tossed together. What is the probability to get at least 1/6? So you three dices are you are throwing together, and you are searching the probability that at least you should get 1/6. So what is the answer for this? Anyone? So whenever you can understand, guys, if you throw three dice, so what can happen, guys? What can happen, guys? If you're throwing three dice, what can happen, guys? You know that, right? Probability of getting a 6. will be 1 by 6. I hope you understanding. Probability of not getting 6, probability of not getting 6, that will be 5 by 6. I hope everyone understand this. And if 3 dice are thrown together, then the total outcome, if 3 dice are thrown together, then the total outcome when the 3 dice are thrown together, when the 3 dice are thrown together, total outcome when the 3 dice are thrown together, then the total outcome when the 3 dice are thrown together, the total outcome when the 3 dice are thrown together, that will be 6 to the power 3, or that will be 216. That will be 216. I hope you are understanding this. Anyone, any doubt, anything, whatever I said? So when 3 dice are thrown together, understand guys, when 3 dice are thrown together, understand that when 3 dice, when 3 dice thrown together, understand that when the 3 dice are thrown together, guys, please understand, when 3 dice are thrown together, guys, you can understand this, when 3 dices are thrown together, okay guys, so you can understand one thing guys, that what can happen, that probability that none of the time will get 6, will get 6, what can happen, none of the time will get 6, okay. So if you throw 3 dice, what can happen, it can happen that none of the time you get 6, it can happen, what can happen, it can be probability that one time you'll get 6, one time you'll get 6, and two time no 6. Can you understand this? Two time no 6, or it can be two time you get 6, it can be two time you'll get 6, and one time no 6, one time no 6, one time no 6, or it can be all the three times you'll get 6. The sum total of this is equal to, anyone, any doubt? Anyone, any doubt? Clear, no? Everyone is understanding, right? So if I say none of the time you'll get 6, none of the time, 3 times you throw, and none of the time you get 6. It just means you're not getting 6. This the your probability of not getting 6. I'm writing like this. This is the probability of getting 6. So not getting 6, you are getting one time you're getting 6, two time you are not getting 6, and two time you're getting 6, one time you're not getting 6, and then all the time you're getting 6. This probability will be equal to, doubt anyone, any doubt? So this is the sum total of all the possible outcome what I can get. Okay, everyone. Anyone, any doubt, any confusion? Now, if I say that 3 dice are thrown together, what is the probability? If I'm saying that 3 dice are thrown together, what's the probability of getting at least 1 6? So 3 dice are thrown together. If I'm saying 3 dice are thrown together, 3 dice are thrown together. If I'm saying that 3 dice are thrown together, probability of getting at least 1 6. Probability of getting at least 1 6. Give you the probability of getting at least 1 6. That means, correct? I get this. Either one time 6, two time no 6, two time 6, one time no 6, or all the time 6. This is what you want, right? This is what you want, right? And everyone, this is what you want, right? Are you getting this, guys? So now this, guys, this is what you are looking for. No? Now this, whenever you get at least, right, whenever you get the scenario of at least, whenever you get the scenario of at least, you can call this is 1 minus, this is 1 minus probability that none of the time will get C. That give you the same answer. So probability of getting 6 is 1 by 6, not getting 6 is 5 by 6. All are independent event. All are independent event. So this will give you the answer. This is 1 minus 215 by, sorry, this is 125, 5 cube, 125 by 216. This I can value 91 by 216. This you can do like this, or you get one, you get once times 6, 2 times no 6. So how many ways this is possible, guys? You getting 1 times 6, no 2 times no 6. You're getting 1 times 6, 2 times no 6. One time, you're this time, first time you get 6, second and third time you don't get 6. Okay, no 6. Then first time you do not get 6, second time you get 6, third time you did not get 6. So it can be first and second time you do not get 6, third time you get 6. So in how many ways this is possible, guys? 3 ways, no? One time you get 6, two time you do not get 6. I hope you are understanding this, right? So how many ways this is possible? So how many ways this is possible? This is 3 factorial by 2 factorial. If you understand, this is 3 factorial, 2 factorial means 3 times this is possible. And probability of getting 6 is 1 by 6. Probability of not getting 6 is 5 by 6. Not getting 6 is 5 by 6 plus, if then 2 time getting 6, 1 time not getting. How many ways this is possible? Again 3 ways. Again 3 ways, guys. So 2 time you are getting, 1 time not getting. So first, second time you got, third time you did not get. First and third time you got, second time you did not get. First time you did not get, second and third time you got. 3 ways possible, guys. So again, this is 3 into 1 by 6. Probability getting 6 is 1 by 6 into 1 by 6. Probability of getting 6 is 1 by 6. Not getting 6 is 5 by 6 plus all the time you're getting 6. So that is only one way. So that is only one way plus. So one way getting 6 is 1 by 6, 1 by 6, 1 by 6. So this is 3 into 25 by 216. 3 by 216 plus 1 by 216. This is 75 plus 15 plus 1 by 216. That is equal to 91 by 216. So you do anyway, you'll get the same. Clear, everyone? Anyone, any doubt? Clear, everyone? Anyone, any doubt? Any doubt? Similarly, if I ask you that four dice are similarly, if I ask you four dice are thrown together, four dice are thrown together, what is the probability? What is the probability? Four dice are thrown together. What is the probability? What is the probability to get four dice are thrown together? What is the probability to get at least two head? Four dice are thrown together. What is the probability to get at least two head? Anyone? Anyone want to solve this? Anyone? Any doubt? Any question? So here when I'm asking you probability of getting at least two head. So I hope you're understanding probability of getting at least two head means so two heads. Sorry, again I'll use the word two head. At least two six, not two head. So if I'm using the word two head means two time you should get six, two time you don't get also fine. Time you should get six, one time you don't get fine. Then all the fourth time you should get six. That you have to find. That is the one case one. That is the one way. So how many ways this is possible, guys? How many ways this is possible? You can do this, guys. This is 4C2. Six ways is there. This is 4 factorial. Divide by 2 factorial, 2 factorial. I believe you know the concept very well. This is 4C2. This is 4C3. This is 4C4. You understand how many ways this is possible. If you want, you can write the cases. So that this would be six ways into two times you get six. Getting six is 1/6, 1/6. Not getting six is 5/6 into 5/6. Plus this is 4C3 is 4 factorial by 3 factorial. Getting six is 1/6 into 1/6 into 1/6. Not getting six is 5/6. Not getting six is 5/6 plus all the four times you're getting six. That is only one way, and that is getting six is 1/6 to the power 4. Total probabilities, you know, that is 1296. So only focus on numerator. So if you only focus on numerator, this is 6 into 5 into 5 divide by 6 to the power 4 plus this is 4 into 5 divide by 6 to the power 4. Okay, this is 1 divide by 6 to the power 4. The probability of getting at least 2 6 is equal to probability of getting 2 6 is equal to 6 5s are 30 na? So 6 5s are 30. 30 into 5 150 plus 20 plus 1 divide by 1296. The probability is 171 by 1296. So, or you can also say this is also as good as if you do by other way. If you do by other way, so case 2, the other way you can say 1 minus probability of no 6 plus probability of 1 6. 1 6 and 3 no 6. I hope you understand. This is like 1 minus 4 time you're doing and none of the time you're getting 6. No 6 plus at least like here 1 6 you're getting, 3 time you're not getting 6. 1 minus none of the time you're getting, not getting 6, 5 by 6 to the power 4. 4 time you're doing. And so 1 time you're getting 6, 3 time you're not getting 6. This is possible how many ways? 4C1. 4C1 means 4 into getting 6 is 1 by 6, not getting 6 is 5 by 6 to the power 3. This is case 2. So 1 minus 5 to the power 4 is 625. 625 plus 4 into 5 cube divide by 1296. This case, this value is 1 minus, this is 625 plus 125 forza, 6 5 to the power 3. 125 forza is 600, I guess so. 125 forza, 125 forza, 20, 8, 10, 500, not 600, 500. 125 forza is 500. That is divided by 129. 1 minus, this is 1125 by 1296. You get 1296, 1296 minus 1125. This is 1, this is 7, 1, 2, 171. 171 by 1296. It's the same answer what you get in the earlier. Clear everyone? You do anyway, you'll get the same answer. Clear? Any doubt, anyone? Anyone, any doubt, any question? Okay, guys, so this much we'll do today. We'll continue discussion tomorrow. Thank you, everyone. I'll see you all tomorrow. And it's not working, guys. Thank you, everyone. I'll see you all tomorrow. Bye.